All right, we're back. We're back. Episode number 5. We're back with Vladimir Vivien. Do our housekeeping. Thank you for everybody that joined us on the live at 11:30 with Tech Stocks and Jobs. We're now here with Mr. Vladimir Vivien with 10 minutes ago. All right. This week, we will continue our Go programming with fundamentals covering struct, array, slice, and map composite types. I'm going to turn it over there to Mr. Vivien. Everybody give him a warm welcome.
Awesome. Thank you. And as Tamika said, once again, welcome to our continuing session on Go, the Go programming. And this is our 5th episode. And we're going to continue with our fundamentals. Again, like I said last time, fundamentals are important. If you're learning a new language, you have to get the fundamentals right, or at least understand what's going on with the fundamentals, because if you don't, then you're going to be frustrated and you're going to give up and you're going to miss out on a bunch of cool stuff, including the money that's out there for folks writing Go programs. So we don't want you to get frustrated, and that's why we spent the last 4 episodes talking about fundamental, and this one included will also be about fundamentals. It's because we want you to understand what's going on, and today we got a full house of stuff to cover. So let me go ahead and keep going. So again, as Tamika mentioned, the whole series is about an introductory discussion about the Go programming language, and we've been doing it for the last 4 Saturdays. This is our 5th Saturday. And if you're interested to see what we've been talking about, take a look, go back in the videos, review the videos, and let us know what you think. Who am I? Well, in this nice and clean shaved picture, I am Vladimir Vivien, software engineer, but also a book author on the Go programming language. Check it out on Amazon. It's out there. Take a look if you're interested in learning about Go. So here's what's going to happen today. As we've done in the past, we're going to do a quick review, and then we're going to look into what's the difference between basic types, which is what we talked about last time, and what we're going to talk about today, which are composite types. And then we're going to dive into our composite types, such as struct, arrays and slices, map, and if we have time, we'll look at some code. All right, let's do our quick review. So last time, what we did, we talked about source code structure. We look at when you open a Go source file, what are the different sections in the source file. Then we talked about declaring variables, how to create new variables and assign values to those variables. We look at the different data types that are in Go. We looked at numeric types. We also looked at other types such as string and Boolean. And one of the last thing we did last time also is talk about what are functions, the different portion of how a function is declared, what's required to build a function, and how to invoke functions. So today, the first thing we're going to do is talk about the differences between composite and basic type. Like I said last time, we talked about what basic types are, and they are your numeric types, like your int, unsigned ints, bytes, etc., your string, and Boolean. Today, we're going to look at other types that uses these basic types to create new types. So this is what I just mentioned. So basic types are your numeric, string, and Boolean types. And composite types are types that can be used as containers for those basic types. And we'll look at several of those types today. So the first one we're going to look at is a struct type. So struct is a composite type that stores one or more values known as fields. And if you don't understand what I'm talking about, we're going to look at a whole lot of examples of what these things are. So don't worry, you'll see what they are. Now, each field in a struct has its own type. Now, struct types are usually declared with what we call a name type, using a type using a type block. And what that allows us to do, what that allows us to do, is to declare the type and then reference the type in different portion of our code. So here's an example of a name type called planet, which happens to be a struct. So here we see the type keyword, and then we have the name of the type itself, the planet, and we have a struct block. Inside that block is where we have our fields, and these fields are basically they'll be values that have themselves, they have their own types. Next, we use the struct literal to initialize the struct. That's one way we can initialize a struct, is with a struct literal. So here's a continuation of that same example where we have a struct type, and then we have a struct value literal that we use to initialize a variable of that type. So in this example, P0 is of type planet, and we are initializing P0 with values: diameter 7926, name Earth, description third rock from the sun. So P0 is a type planet, and planet is a struct. So I just want to make sure you understand what's going on. And the field values, and so one of the things that you probably didn't see, but we use the dot operator or dot notation to access the fields that are in the struct. So if we go back to that same example, we see that P0, which is declared up here, we see that we can access field name, which is this guy, by using the dot operator followed by the name. So when we do that, we can get the value that was stored in P0, which would be Earth in this example. Now let's go to arrays. Arrays is another type of what we call composite types in Go. They store a sequence of items of the same type. In arrays, in Go, I should say, arrays are static, meaning once you have once you declare an array of a certain size, that's it. The array doesn't grow, it doesn't necessarily shrink, but you can access different items inside that array once you have it. Array types are declared by specifying its size first as part of the type, and also the type of the items that are stored inside that array. So let's take a look. Here is an example of an array. Here we have the bracket that we talked about, and inside that bracket we said, I want an array of size 7 in this example. And then we have to tell Go what is the type that we want to store inside that array. In this example, it's just happened to be a string, but it can be any type, really, whether it's a composite type or a basic type we can store in that array. So what I mean by that is an array can also store other composite types, not just basic types. But in this example, I'm just showing you that I'm showing it as storing string. And then once you have that, you can initialize that array with an array literal block value, as we're shown here, where we're just passing it seven string values of the name of the actually it's 5 values, sorry, of the name of the weekdays. And then to get to the values that are stored inside the array, we use what we call index expression. And basically the index expression is what you put inside the bracket to let the compiler know, or to let Go, the program knows which item in the sequence that you're interested in either getting out of the array or update inside the array. So in this example, we're pointing to the third item. The third item. And the reason why it's the third item, I didn't mention that earlier, is because arrays are zero-based index, meaning that this is item 0, item 1, item 2, item 3, item 4, and so on. So here we're interested in the third item, but because it's 0 indexed, we say it's this. We put number 2. Hope that makes sense. And if it doesn't, put a question in the live. All right, let's talk about slice. So we've seen what arrays are, and we say that arrays are static and we can't basically grow once you declare the array. And actually, I want to point that out before I go into slice. One of the problem here, I didn't specifically point it out, but if we put an invalid index here, like let's say we say that this array is of size 7, and we put an index outside of that boundary, then the compiler at runtime, actually the program at runtime, will yell at us saying, "Hey, I can't access that position," and there's nothing you can do about it because it's an array. Once you say it's 7, then it's 7. Now let's talk about slice. Slices, on the other hand, they're dynamic. They work similarly as how array work, as far as using a numeric index to store data, to store sequence data. But the container that you use in Go for your slice can grow, and we'll see how that is done. Slices are declared with a bracket, just like we did with array, with the exception that now you don't put a size in between the bracket because it's dynamic now. So here's an example of a slice. Here we see that we start with an empty bracket because we omit the size. So the compiler knows that that's an array. I'm sorry, that's a slice. But you still have to tell it the type of the slice. So that's what we're doing here. We say it's a string. And then similarly to what we've done with the array, we also we can initialize that slice with a literal block of data. So that's what we're doing here. And then here, just like we did with the array, we can use an index expression to get to the item inside the slice. Now, we saw that slices can be made using an initial value using a block literal. But another way we can initialize an array, or a slice rather, is with a built-in function called make. And this is what we're showing here. We use the function make to say that we want to create a slice of size 3. Now, what does that mean? That means after that line of code here, we're going to have a slice with 3 slots allocated for us. Now, we can go in and add value in these first 3 slots. But what we can't do is go beyond that. Even though I said slices can grow, but the way we tell the compiler that we want it to go beyond what its original size was, we have to use the append. So there's another function, built-in function in Go called append that allows you to basically grow your slice as you see fit. And that's exactly what we're doing. So at this point in the code right here, we've gone past the original size of 3, and we added 3 additional items to the slice. So that means at that point right here, we are at size 6. Maps. Maps are basically their key value pair storage container that we can use. And basically, the way maps work is you use an indexed element similar to how we did with array and slice, but instead of the index always being a number, just like in slice and arrays, in map, your index can be an arbitrary type, or we no longer call it an index, but we call it a key. So the type of the key doesn't have to be a number, just like in slice and array, it can be any type. So map types use the map keyword, so you can declare that you want to use a map. And here's an example. Here we have the map keyword here, and we also say the type of the key that we want to use, and then the actual item type. So in this map, the key will be string, and the value that we store for each item is an int. And that's what we see here. For instance, we see key January value 100, key February value 445, key March value 514, etc., etc. And then here is an index expression that allows you to, because it is an index type, really, you can use this index expression to extract value out of the map or update existing value inside that map. And that's what we're doing here. So if you wanted to understand what's going on in the rest of the example, what we're doing is we're combining types now, because now we understand what's going on. Because we've been covering our fundamentals, we should understand what's going on. So what we're doing here in this part of the program, we're creating a slice of int, right? And inside that slice of int, basically what we just talked about, we're going to put numbers. And what we're going to do is extract numbers from the table variable and put them inside that int. So when I say table April, that first number is going to be 233. When I say table May, that second number is going to be 321. And when I say table June, that third number is going to be 644. And we put everything inside a new value, which happens to be of a slice type, and that's Q2. And when you access Q2 and you print it, you'll see 3 numbers printed. Maps can also be initialized with make. So similarly to what we've done with slice, we can do the same thing with make. Here we see that we use make, well, before we get to that point, and we pass make the type of the map that we want. Now, again, after this point in the code, basically what we're going to have is an empty map. But inside that empty map, we can now go and put values inside that map. And that's exactly what we're doing. And the rest of the program is basically the same thing that we saw. So let's look at some code. Before I jump to the code, let me check to see, do we have any question? Let's see. I don't see any questions. Okay, cool. So let's look at some code real quick. All right, so here's the example, the last example. Actually, let's go back to the struct and talk about the struct real quick. So this is the first example we looked at, the struct. Let me make sure this is not too, I think this is, the size is good enough. Okay. This is the first example we looked at, the planet example, and this is a a variable called planet, and we put a value, we declare planet, and we use a planet literal value and assign that value to P0. So one of the things we could do also, just so you can you want to make sure you understand, let's see if we had another planet. We could always do this, planet of type, I don't know, P1, and that planet would be of type planet. And after we declare that, then we could say name equals, I don't know, Mars. And then we could say P1 dot diameter. I'll just make up a number. 5. I know that much. I know Mars is smaller. So then P. No, okay. Actually, I could stop there. I want to show you that you don't necessarily have to provide all of the fields. It's, you can provide as much as you want or as little as you want, because the minute when you start that planet, when you create that variable here, it creates, if you remember, we talked about what the zero value of a variable is. And basically that planet, that P1 variable, once you come here, each field inside the value will have its own zero value, meaning this will, after this line right here, this would be 0, this would be empty string, and this would be empty string. And then once you can come back and update these values as we've done here. So I just want to make sure that it's something that that you all understand. All right, let's go and take a quick look at. Hang on once. There you go. Let's take a quick look at arrays to make sure arrays are sinking in. Okay, so with arrays, as I talked about earlier, here, and I noticed that while I was talking about when I was talking about the slide, weekdays. So it's, even though I say it's 7, but I only have 5 items in there, which is okay. All right, so you can always have an array with less value than the declared size. What I cannot do is something like this. Actually, let's show it like this. I'll make up a day. My day. Your day. Workday. Now, so because I say this is an array of 7, after the 7th item, let's see, right here, at runtime, if I run this program, it'll blow up. Matter of fact, let me see if I can run it. Let me check. All right, so where are we? Let's see the array. All right, so let me make sure this is saved. All right, now it's saved. So now if I run it, so you see that actually, I think I have an error. Yes, I have an error because I have everything on multi-lines. And that's one thing in Go that you should know is you put the separator, which is a comma, at the end of each line, even at the end of the last line. That's what I was missing. So now, okay, so that's what I was expecting to see. Array index 7 is out of bound because the last item in the array is beyond the size of the array, which is right here. So that's one thing I wanted to show you. Now, if we go in, let me undo this. Let's go to slice real quick. So we see slice, and slice would have slice, even though I said that slice grows by itself or is dynamic, I should say, slice can grow. Slice would have something similar of an issue, right? So if I come here And so this slice would be what, 12? So let's print that, fmt print. So there's a special function or a built-in function called len, L-E-N, that'll give you the length of slices, arrays, and maps. So here we're going to put months in there. I'm going to print that. So if I come back here, sorry, slice. Error. Print ln. There you go. Okay, so we see that it's size 12. Let's see if I'm able to add a 13th item directly. So it's size 12. Let's see. All right, let's see what happened. So we see that we have a runtime error. Again, we out of range. Now, even though it's a slice, because we started out with a specific size, it still has a boundary that it says, hey, you can't go beyond that boundary. If you want to go beyond that boundary, what you have to do, as I had mentioned earlier, you have to do something like this. You have to tell it that you want to append 2 months, something new. And that's what we just did here. Now, if we do that, look at what size says. There you go. So now I'm able to add. I'm able to add to months using the append, and I'm able to change the size of the slice with no problem at runtime. All right, so those were the things I wanted to point out. As I've said, I think after today, I should say, for the next episode, we should be able to start creating programs. And again, if you start to get lost after today, refer back to all of the fundamentals that we talked about for the last 4 sessions, including this one, and you should be able to catch up and understand what we're talking about. But after today, we're gonna start creating programs and talk about Go as if you know what's going on. And if you don't, refer to the previous fundamentals so you can catch up. We might cover a couple of fundamental things just to make sure that things are making sense, especially when we talk about when we're going to talk about object-like values and methods, etc. We might cover that with fundamentals. But after today, we're going to jump right into it and start writing programs and deploying them and play with them and really have fun with Go. That is it. So now I'm going to look to see if we have additional questions and talk about them.
And we do have questions. Kevin, thank you for joining us. Thank you for all that have joined us. Kevin asks, does a slice have an underlying array that gets rebuilt once the append method is run?
Absolutely. That question sounds like somebody has been doing their homework or they know what Go is all about. Yes. So slice, underneath slice is an array. And not just an array, but also there are pointers that allows us to keep track of what's inside that, or I shouldn't say pointers, but there are other types or values that are part of the slice that allows us to keep tab of what's going on inside the slice. And as we change the size, those values are being updated to reflect the size of the array as it changes. So hopefully that makes sense.
And the next question was, are arrays immutable in Go?
So the items are not. The items are not. What I mean by that is, once you create an item, once you create an array, you put items inside that array, you can change those items as you see fit. A value, so that's that. Now, a variable, which is an array, is also not immutable, meaning that if I have an array A1, I put one array in it. I can put an array A2 inside A1 as long as they are of the same type. Now, this is a very good question, and I will switch to my code to continue to answer it. Let me go in array. Let's do a new file. We'll call it array3. All right. So what do I mean by that? So let's package main func main. So if I have an array 1 and I say that array is, I don't know, 3 int, right? 1, 2, 3. Now, A2, if A2 is, let's say A2 is also something like this. Int 4, 5, 6. Now, what I can do is say A1 is equal to A2. And Go will perfectly be happy. Let's do a print statement here. Let's A1. So that this will be happy. Okay. So now Go is perfectly happy because we're saying I can take A2 and assign it to A1 because they are of the same type, even though the values are different. But this portion right here is the same. So that means they're of the same type. However, if I make this an unsigned or something else, it immediately says, hey, these are not the same type, because even though they're of the same size, but the items inside are of different type. And uint is just mean unsigned int. It's a value. It's a type where the values range from 0 to the top value, whereas your regular int range from negative, the max negative to the max positive. Anyway, so two different types, even though they're all numbers, even though the size of the array is the same, but because they are of different type, I cannot do that assignment and I cannot update. But as long as they are, I can update that value. And obviously I can also update the values in the elements, as I said, the items inside the arrays as well. So I can always say A0 is equal to, I don't know, instead of 1, let's make it 4. And that's perfectly legal. So everything is immutable. So you can change the items that are inside the array. And you can change the actual array variable itself, as long as you're assigning it something of comparable type. So hopefully that makes sense. Anything else? Any other questions?
Yep, you got another question. It says, if you need to reduce an array, is there a command similar to append for that functionality?
No, there's no reduce. What you okay? So let's go. Let's create a new one. Man, y'all got some good questions today.
Keep you on your toes.
I see that. I can't just
Kevin
show
said,
up.
you can't just show up and not do no coding. I don't know why you think that's what you do.
All right. So here's what the question asked about reducing size. Where is it? Size. Okay. So let's do package main func main. All right. So if we have so first of all, to completely answer the question, arrays you cannot change the size of, right? So once you have the array, you cannot really mess with how big it is. It's static. Slices, on the other hand, is what you can change the size of by appending. But let's start with a slice one, and we're gonna say it's a slice of days or something. All right. So we can say Monday, Tuesday. Okay, so now, oops, sorry, not days, string. Anyway, now we have a slice with 3 items, 3 string items, and the size of the slice is 3. What I can do is I can get what we call a sub slice, or we can get a slice out of the slice, really. So we can do S2. We can say it's S1, and we could say starting with 1 and end it at 3 or something like that. So that would be the. Actually, that's not a good example. So I just create a slice out of a slice, right? So that slice is smaller than S2 is smaller than S1. So I'm saying all this to say that there's no specific function that says, shrink or make smaller or anything like that. There's always append, but you can always take a slice out of a slice to get a smaller slice. So you can imagine if I'm inside a function, I get something that's passed that's this big, I can return something that's that big once I'm done with it. Let's put FNT and S2. Let's see what that looks like. All right. So if I was to run this, which one is this? Make sure we save this. So there you go. It's it's Wednesday. 0, 1, 2. So if we look at what this expression is saying, 0, 1, 2, and then go to the maximum size. So that's what we're doing here, and that's why it's returning Wednesday as the element. And this is what we call a slice of a slice. Hopefully that makes sense. Anything else?
Yep. Last but not least, for everybody, I know we talked about IoT devices and so forth. I posted the link inside the chat on the different platforms that Go can use for IoT devices, in terms of your PIC controllers, your GPIO, your drones that it can be used with, and also not least the I2C drivers and SPI drivers and the API, just so you can have a reference to that for those that want to use, may want to practice Go with some robots and so forth. And remember, we were talking about IoT devices before. And there, yep, Vladimir's holding up his IoT devices with
Right.
us.
So this is a the Raspberry Pi Zero. It's like one of the tiniest one they got, and I'm able to run Go in there. And there's a camera, if you could see, that's attached to it. I haven't. I'm not finished with this project, but this is running Linux, and it's an ARM chip, but it can run Go on there, and you can do some interesting stuff. So maybe that's something we talk about at some point.
Cool. You did have another question. Working with dynamic data equals use slices, and working with predetermined data equals use arrays.
Yeah. So to be clear, um, when you go and read about the Go programming language, you rarely see people using arrays directly, because slices give you, it's so much more convenient to just use a slice and be done with it, because you never know when you might add something, add an additional element. Um, and as we mentioned earlier, slice really is using an array underneath. So idiomatic Go, in all the literatures that you're going to see, most likely they're going to start using a slice from the get-go. So I wouldn't, I mean, I put arrays in there for completeness, but most likely you're going to be using slice, if that makes sense.
Makes plenty of sense. And we came to the end. Thank you, Rhonda and Kevin, for joining us. We appreciate you and all those that are watching as well too. Let us know if we can help you on your Go journey. If you have questions, you know where to find us in Slack. Also, if you are wanting to know more about Go, pick up Vladimir's book. Spread some love.
Absolutely.
Spread some love. And as well, we're going to catch you again next week. As you heard before, we're going to be doing a little bit more. Go ahead and take a look at that link on embedded devices or and drones for with Go. And also, what was the name of the device that you had? Did you just show?
Oh, yeah, this is basically a Raspberry Pi, but it's the Raspberry Pi Zero, which is the small form factor. If you're familiar with Raspberry Pi, I have another one here. I don't see it. But anyway, there's one that's about twice as big, but they also have like tiny ones. And it's a full computer running Linux. It's an ARM computer, but you can run regular Go on it. And that's one of the things you can do. But the stuff that Tamika is talking about, the GoBot is a great website. You can run Go on things that are not running Linux, things that are running their own or no operating systems at all. So it's a great place to go and find out about interesting projects like the drone controllers, etc. But yeah.
Sounds like I need to get my drone fixed, huh?
Yeah,
So we can play with the drones.
absolutely.
All right, people. Thank you, Mr. Vivian. We appreciate you. Thank you,
Absolutely.
everybody that's in the chat. D, thank you for the drops and the fly hands for everything. We'll see y'all next week.